How can I store related data of different types? How is a table of values stored in an array? What does dimension mean? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 46th video in the Introductory Programming in Java full course and the 7th video of the final lesson, Lesson 7, Arrays and ArrayLists in Java. In this video, we're going to look at parallel and multi-dimensional arrays. Let's get right into it. Let's start with a problem. Your friend group watches classic movies, as defined by you and your friends, and you want to write a program to store your ratings. You could create an array of objects, but you want to explore other options. Is there another way to store many movie titles and ratings so you know which title goes with which rating? You start to sketch it out, and you end up with two parallel columns, like in a spreadsheet, with titles in one column and ratings in another. Staring at the columns, you realize that the rating in row 1 is for the movie in row 1. The rating in row 2 is for the movie in row 2, etc. If you store the movie titles in an array of strings and the ratings in an array of integers, as long as you store them in the same order, the indices will relate the movies to their ratings. The movie at index 0 in the movie titles array will have the rating at index 0 in the ratings array. In programming, we refer to arrays related by their indices as parallel arrays. If you move on to data analytics, this is how tables of data are stored in languages like R and libraries like Python's pandas. Each table is a list of same-length vectors of different types of data. Let's see how to solve this in Java. This program is called simplemovieratings.java. In this program, we've defined two arrays, an array of strings called movie titles, and an array of integers called ratings. Each array contains 11 elements, and they are related by index. So your rating at index 0, 9, is for the movie at index 0, Casablanca. And your rating at index 7, 5, is for the movie at index 7 that your friend Milo insisted everybody watch so they would get his fèche la vache jokes. The program then prints the movie titles and the rating. I'll run the program so you can see the output. Notice that in the code, we have one loop with one index, I, that we use to index into both arrays. In the loop header, we have for int I equals 0, I less than movie titles dot length, and I less than ratings dot length, I++. I included a test against the length of both arrays as the end condition for the loop, just in case the arrays get out of sync. We accidentally add a movie without a rating or vice versa, but technically parallel arrays should always be the same length. Within the loop, we're printing movie titles sub I and ratings sub I, two values that will relate because we are using the same index into the two arrays. I have some code below, commented out, that further illustrates how useful parallel arrays can be. I'll uncomment it. It prompts the user for a movie title and displays the rating for that title. We can do this by finding the index of that movie title in the movie titles array, and then using that value to index into the ratings array. So if the user searches for Alien, we will sequentially search movie titles for a match to Alien. We will find it at index 3. So we'll use index 3 to index into ratings, finding a rating of 10. The first code should be familiar. On lines 29 to 32, I'm obtaining a movie title from the user. And on lines 35 to 42, I'm sequentially searching the array for a match to the title the user entered. If I don't find it, the index will be -1. And if I do, it will be the index of the movie title. On lines 46 to 50, I print a message to the user, either that the movie hasn't been rated if the index is -1, or the rating of the movie. Notice that I print the rating by using the variable movieIndex to index into the ratings array. Now, suppose your friends find out about your ratings program and they want you to add their ratings. What would that look like? If you add their ratings to your original sketch, you find that, again, it looks like a spreadsheet, but with more columns this time. One column for the movie titles, one column for your ratings, and then an additional column for each of your friends' ratings. You could solve this the same way, by adding additional parallel arrays. You would then have an array of ratings for you and each of your friends, with all of them parallel to the array of movie titles. But because the ratings are all the same data type, integer, you could store them all in a single array. It would be a two-dimensional array, an array of arrays. Let's talk about the word dimension and what that means in this context. In programming, the dimension of an array refers to how many levels of indexing are needed to access a single element. A one-dimensional array is a simple list. You use one index to access each element. A two-dimensional array is like a grid or table. You need two indices, one for the row and one for the column. A three-dimensional array is like a stack of grids, and after that it becomes harder to visualize more dimensions. A two-dimensional array is an array of arrays. It can help us visualize algorithms to think of it as a table with rows and columns, but practically we are defining an array in which each element is an array. This program is called two-dimensional movie ratings.java, and you can see at the top we have the same array of movie titles. We then have an array of your friends' names. More on that later. The next declaration is a two-dimensional array of ratings. Let's look at the data type first. It's int, open close square bracket, open close square bracket. Remember the data type for an array. It's the data type that will be in the array, followed by open and close square brackets. So we have int, open close square brackets, meaning an array of integer. We then follow that by open and close square brackets, meaning the data type in the array will be an array of integer. So ratings is an array of arrays of integers. I've hard-coded values into this array just as I did in the other program. So you can see that we have curly braces enclosing a series of arrays of integers separated by commas. Each array of integers corresponds to the ratings for a single movie. So, for example, our first array of integers, which is the array at index 0 in ratings, corresponds to our movie at index 0 in our array of movie titles. Those are our rows. Our columns are ratings from a single person. So the first column represents your ratings of the movies, and then each additional column represents a friend's ratings. Luckily, your friends have really short names to make it easier to comment the code. Now, we'll want another parallel array for the columns, so I've defined a parallel array for your friends' names. That is a one-dimensional array, string names, and then the comma-delimited list of names in curly braces. You can substitute your real friends or family in here if you're programming along with me. Now, how do we access an individual rating in the two-dimensional array? Let's break that down. Once again, it is an array of arrays. So if I access ratings sub 0, I am accessing the first array of integers within the array of arrays. Ratings sub 0 is the array 9761058. That's everybody's ratings for the movie at index 0 in the movie titles array. I can further index into the structure with another index. So ratings sub 0 is 9. The rating at element 0 of the array at element 0 in ratings. If we picture this array as a two-dimensional table, you can see the indices of each of the elements in this graphic. The first index gets us to an array, which we think of as a row, and the second index gets us to an element, which we think of as a column. So the indices of the elements in the first row are 0, 0, 0, 1, 0, 2, etc. through 0, 5. And the indices in the second row are 1, 0, 1, 1, 1, 2, etc. through 1, 5. This proceeds through the index of the last element in the array, 10, 5. Now before we look at some looping algorithms to loop over this array and average the ratings for each movie and the ratings given by each friend, I want to show you how you declare and instantiate a two-dimensional array if you're not going to instantiate with literals, as I have in this example. To instantiate our array without filling it at the same time, we would write ratings equals new int, and then in square brackets, we put the number of rows. For this array, that's 11. We have one row per movie. In the second set of square brackets, we put the number of columns, which is 6. We have 6 people rating the movies. Now let's look at our looping algorithms. With this array of data, we might want to know the average rating for each movie. If there's a movie you all really loved, maybe you'd enjoy another movie in that genre. We might also want to know the average rating given per person. So if Leah doesn't like a movie, the rest of you might still like it because Leah is a very discerning critic relative to everybody else. Our first block of code, on lines 40 to 56, finds the average rating for each movie. Now think about what that means. We'll want to add up the values in each row and average them. You know how to add up the values in an array and divide by the total number of values. The only trick here is the array you're averaging is itself within an array. The other little glitch is that not all friends watched all movies, so there's the occasional -1 in the ratings, meaning no rating. We have to make sure we don't average or count the negative ones. When we're looping over every element in a two-dimensional array, we use a nested loop. If we loop in row major order, it means we will start at the first row and visit every element in the row. Then we'll move to the next row and visit every element in the row, etc. When we loop in row major order, our outer loop iterates over the rows, and our inner loop iterates over the elements in a row. Looping that way means we'll be visiting all of the ratings for one movie, then we'll visit all the ratings for the next movie, etc. So that is the way to loop over our two-dimensional array if we want to average the ratings for a movie. That's what our first loop is doing. Our outer loop is for I equals 0, I less than ratings.length, I++. The variable I will take on the indices of each array in our outer array, or each row. Inside that loop, we'll initialize our accumulator and counter variables to 0 to prepare for totaling the ratings for one movie. And then we'll loop over all of the elements in the row. The row is ratings sub I. So we'll loop for j equals 0, j less than ratings sub I.length, j++, and we'll check if the rating is -1, and if it isn't, we'll add it to our total and increment our count. A rating is ratings sub I sub j. Ratings sub I is a single row of ratings for a movie, and ratings sub I sub j is the next rating in that row. Once we're done totaling the ratings for one row, or one movie, we can average it by dividing total by count and print the result. We can use our parallel array of movie titles to customize the output, so we give the name of the movie and the average rating for the movie. The movie title is in the array parallel to our outer array, so we'll use I to index into movie titles. When we loop in column major order, our outer loop iterates over the columns, and our inner loop iterates over the elements of a column. Looping that way means we'll be visiting all of the ratings for one person. Then we'll visit all the ratings for the next person, etc. So that is the way to loop over our two-dimensional array if we want to average the ratings from a person. To do this, we are basically going to reverse our I and j loops. So put our j loop on the outside and our I loop on the inside. An element in the array is still rating sub I sub j. We're just changing the order that we're visiting them in. The outer loop will start at the second index of 0, and then the inner loop will visit the first index of 0, 1, 2, etc. through 10. So we'll visit 0, 0, then 1, 0, then 2, 0, etc. through 10, 0. Then we'll update the outer loop, and we'll visit 0, 1, then 1, 1, then 2, 1, etc. through 10, 1. This requires that all of our rows have the same length, because we're going to have to pick one and use that length to control the outer loop. I've picked row 0, so my outer loop reads for int j equals 0, j less than ratings sub 0.length, j++. And then the inside is the same. Make sure this isn't a -1, and if it isn't, total and count. And the summary is also very similar. If we had some ratings, display them, and we can customize the output by using the array parallel to the ratings, which is the array of friend names, and we index into that with j, because j is the variable iterating over columns. Multi-dimensional arrays are something you want to practice with. Draw pictures and rewrite code like this from scratch. Create your own two-dimensional array of data that's interesting to you, any data of the same type that can be stored in a table. You could store weight lifted, miles run, rainfall, or slices of pizza eaten in a two-dimensional table of days in columns and weeks in rows, for example. Or you could rate donuts, cookies, TV shows, or video games with your friends and make a table like the one in this video. Practice, draw pictures, and loop through the array in both row major and column major order until it feels second nature. In this video, we looked at parallel arrays, in which data in two same-length arrays, usually of different types, is related by the index of the elements. We then looked at two-dimensional arrays, in which data of the same type is stored in arrays that are themselves stored in an array. We looked at how to loop over two-dimensional arrays in both row major and column major order. I hope you found this video useful. As usual, I've included some auto-graded exercises in the description of this video so you can practice with this code. And the video code is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.